In these problems, we're talking about raising things to the 0 power. And there's kind of an interesting, simple rule with the 0 power. Anything raised to the 0 power equals 1. So, for example, 5 raised to the 0 power equals 1. 1,000 raised to the 0 power equals 1. X raised to the 0 power, even though I don't know what x is, I know it's going to equal 1 because anything raised to the 0 power is 1. So that rule should make these problems a little simpler. Let's take a look at this one. I'm going to actually start from C and work my way backwards because C is the easiest. 5 is raised to the 0 power. What does that equal? Well, it equals 1 because anything raised to the 0 power is 1. And now we have 5 raised to a negative power, a negative 3. And you should remember that when something is raised to a negative power, you put 1 over that number raised to the positive power. So that's 1 over 5 to the third, and 5 to the third is 125. So we've got 1 so far, and 1 over 125. The last one here looks a little more complicated. We have a 1 over 5 to the negative third. You could think of it like this. This is 1 over, and 5 to the negative third is 1 over 5 to the third, just like we did there. That looks a little complicated, though. What this ends up doing really is just flipping it around. So you have 5 to the third over 1, which really is just 125. Let's look at this next problem. This looks pretty complicated. It says use the distributive property to expand. And remember, the distributive property is where you have a term outside the parentheses, 2 different terms inside the parentheses, and you kind of multiply them through. In this case, we've got some 0 powers in here. So the first thing we want to do is simplify the 0 powers. Let's look at this term out front of the parentheses. We have x to the 5th times y to the 0 times z. Well, y to the 0 is 1. Because anything to the 0 power is 1. And x to the 5th times 1 times z, well, it's almost like that 1 disappears because anything times 1 is still itself. So we can rewrite that term out front as x to the 5th z. So already it's a little bit simpler. Let's go to the inside of the parentheses. Now here we have t to the negative 3 z to the 0. Well, that's t to the negative 3 times 1, which is just t to the negative 3. So that's looking a bit simpler. And then our next term we have plus 7x to the negative 5th, z to the negative 1. And there's no 0 powers to simplify there. So now we're at the point where we need to take this chunk and multiply it first by this guy and then by this guy. So when I multiply x to the 5th z times t to the negative 3rd, we just kind of stick all those together. So x to the 5th z t to the negative 3rd. And then I have my plus sign. Bring that down. And here we have x to the 5th z times 7x to the negative 5th z to the negative 1. I'm going to smash those together too, and then we'll have to do a little simplifying. So I have x to the 5th times 7 times x to the negative 5th times, well, I have my z from out here, and then times z to the negative 1. I put them in that order so they're kind of next to each other. What you should notice is that we have some of the same terms. Z is really the same thing as z to the 1st power, z to the 1, and then times z to the negative 1. You might remember that when you multiply with powers here, you add the powers. So z to the 1st times z to the negative 1st is really z to the 1 plus a negative 1, or z to the 0. So this guy becomes z to the 0, which is just 1, which can disappear. So we'll cross that out. Likewise, we have x to the 5th, x to the negative 5th. When you multiply those together, it becomes x to the 5 plus a negative 5, or x to the 0. So that becomes x to the 0, which is 1. So the only thing that's really left here is 7 times 1, which is still just 7. So this is looking a little bit messy, but what we finally end up with is x to the 5th z t to the negative 3rd plus 7. Let's try one more of those. So a lot of steps there. That can be pretty complicated. So the first step is looking for any 0 powers and realizing that they're the number 1, and since they're multiplied by these other things, they're going to disappear. Well, here's y to the 0. It's a 1. I'm going to cross it out. Here's z to the 0. It's a 1. I'm going to cross it out. Now let me rewrite this. We have x to the third z times p to the negative 5 minus 9x to the negative 3 z to the negative 1. So first, we'll take this chunk and multiply it by the first term, p to the negative 5. Well, since they're all different variables, we'll just smash those together. X to the third z p to the negative 5. That's the first term done. Then we have a negative sign. And now we have x to the third z times 9 times x to the negative third times z to the negative 1. Just put all those in the order that they came. What we have to do next is some combining of the like terms here. We have an x to the third times an x to the negative third. We add those exponents. We get x to the 0, which is 1, so it's like they disappear. Z is z to the first, and then there's a z to the negative first. Again, we add their exponents. We get the z to the 0, and it's like they disappear. So all that's left here is 9. So our final answer is x to the third times z times p to the negative 5th minus 9. So complicated looking problems, but if you take it a step at a time, not too hard.